Hi, my name's Brad Burns and I work for Google. I'm really excited to talk to you today because if you're a researcher, a sponsor of research, or you work in IT, we're going to be able to help you find data sets faster and get to new knowledge quicker than you can right now. How are we going to do that? First, to make research faster, we're going to help you quickly find data sets. We're going to help you reduce the time it takes you to analyze things, and we're going to help you collaborate with other researchers on your team. And to help you generate new knowledge, we're going to help you be more innovative by joining data sets that you might have not joined before. We're going to give you access to cutting-edge techniques for analysis, and we're going to help you visualize those results in new and exciting ways. We talked a little bit earlier about the different types of people that we're going to be able to help out here, but I wanted to talk for a second about who these different personas are and what they care about. So on the left-hand side, we have a research sponsor. This is from the fictional Illinois Department of Mollusks. Apparently mollusks are very, very important here in Illinois. That research sponsor is essentially paying for all or part of the research that's being conducted. They want to get faster answers to questions that are harder to answer. In the middle, we have a researcher. Often these are referred to as research affiliates or RAs. This researcher wants to focus on generating knowledge, doing the analysis, proving and disproving hypotheses, rather than finding, cleaning, wrangling data. That's not the fun or useful part of research, combing through a CSV file, trying to see if things are misspelled. Like, they don't want to focus on that. And then from an IT perspective, IT wants to empower the researchers to do the analysis that they want to do faster and easier, but also while maintaining protections around operations and security. They want the system to get out of the way of the researchers, but still be safe. This is how Google's tools fit into a typical research process that we're going to show a little bit later on. First, on the left-hand side, we have a couple of data engineering steps. Now, what is data engineering? Data engineering is the process of creating what's called a data product, or building a data set that is consumable by researchers, analysts, etc. The first step that you need to do is you need to load data into a place where it can be accessed. The second step is you need to clean that data to make sure that if you do a query for the first name Brad, it's not spelled 12 different ways. You'd be surprised at how people can do that. The third step, as we start getting into the data analysis side, is finding that cleaned data. So how do we easily access that data? Right now, you might have data in 15 different databases across 30 different on-prem servers, storage systems. You might have some of it uploaded to some cloud somewhere, or in a drive or box or something. How do we unify all that into a single place and make it very, very easily searchable and scalable? And then after we find the data, we need to analyze it. So we need to pull together an analysis that helps us get closer to the question that we're trying to answer. And then finally, review and visualize the results. Underneath that sort of chart there's a bunch of different products. I'm mostly leaving that as a leave behind. You can look at this later, but I will be showing you each one of those products and how they're used over the course of the demo in a moment. What are the benefits of each of these products? The green boxes at the bottom basically talk about the benefits of adding all these different things in. So first, on the loading and cleaning data side, we're going to eliminate storage capacity constraints. What does that mean? That means that you might have an on-prem NAS or SAN disk array right now that's running out of space because you keep adding data to it, or you might have an issue where you're not able to provide the appropriate level of data protection because you need twice the amount of disk to protect against disk failures or something. That is not a concern with Google Cloud. Google stores actually multiple copies of the entire internet, and Google moves that around among its different data centers multiple times an hour, quite frankly. So Google has plenty of storage, and there's more than plenty of storage for what PRI can bring to the table as well. we can easily access that storage through both a SQL interface or a G-Cloud, which is a command line interface. There's a lot of different ways that we can get access to that data. But it's one thing to get access to the data, but it's another thing to actually be able to find it. And the tool that we're going to be showing you today is Google Dataplex, which is basically Google search for data sets. Then when we actually go to analyze the data and review results, we want to make sure that you can perform that analysis as quickly as possible without waiting for supercomputer time or for your beefed up desktop or laptop to churn through all that data. We'll show you a very big data set later. And then we want to also be able to help you join between those multiple data sets. So where you might have different silos of data sets today, we want you to be able to access them through a single interface and be able to perform analyses on multiple interfaces without having to set up a bunch of different data pipelines to do a database connection to this SQL database and then read from a CSV file here. No, we want to be able to analyze that all within the same query or function. So our scenario for today is the Illinois Department of Mollusks, again, very important, wants to know how pollution affects clams, snails, slugs, all the different types of mollusks there are in the state of Illinois. And so they've come to the Prairie Research Institute and said, okay, tell us how pollution or pollution remediation affects the health of mollusks in Illinois. So we're going to be going into that. We're going to be exploring that question today. And I'm going to move over to a different window here. So the first question is, what is a mollusk actually? So we type this into Google. A mollusk is a phylum, that's interesting, of soft-bellied, usually shelled invertebrate snails, clam, octopi, squid. So it looks like, oh, cool, all kinds of mollusks here. I'm not sure how many of these are in Illinois, but we're going to find out. Clearly, there's an entire department dedicated to mollusks just here in Illinois. Oh, it can be snails too. That's cool. I also happen to know that slugs are a type of mollusk. So mollusks are a phylum, right? So a phylum is part of an animal classification taxonomy. You're probably familiar with species. So Homo sapiens is the species for human, what we are. There's a lot of different species in the world, and some of them are contained under the mollusk phylum. Class under mollusks include gastropods, which are snails and slugs, for example. But interestingly enough, at the Prairie Research Institute, there's actually something called the Illinois Natural History Survey. And the Illinois Natural History Survey does surveys on types of species that are identified, as well as occurrences of those identified species, meaning when you find a new animal or insect or whatever, you first want to name it, and then you want to report all the times where you've seen it as a researcher. So you see people going out in the field all the time, they see a slug, oh cool, pick up the slug, see what kind of slug it is, and then they enter it into this data set with where, when, and what kind of slug they found, or mollusk, or clam, or whatever. This database is really cool. There's over 500,000 specimens that are cataloged, and this actually all comes in the form of a CSV file, or comma-separated value, which is a flat text file. Another thing a way to look at whether or not pollution is affected by mollusks is to see how Superfund sites may have affected the mollusks themselves. Now, what's a Superfund site? So the Superfund program was established during the Carter administration. And basically what it is the federal government, the EPA, identified hundreds of tens of thousands of sites that are the most polluted sites across the entire United States. So really, really, really bad stuff. I'm talking about like dioxin leaching into the soil, arsenic, really, really nasty stuff. And there are actually some of these Superfund sites that were inside of the state of Illinois. So if we actually look, there's a Superfund site in the middle of, just outside of Springfield, believe it or not. And it's in a little town called Taylorville. And this site, I'll show you in the bigger map later, but this site right here used to be, or still is, a Superfund site. And this used to be part of an Illinois, the Illinois Public Utility Company or something like that. This is what it looks like today. So you can see that this place has pretty much just been absolutely stripped bare. Heck, there's even like, cameras that are set up to observe the site, do not enter signs, like any sort of foliage in this place has been completely stripped. And if we actually go back to before it was remediated back in 2013, you can see that this place is a little bit nasty. So if you look here, there's a bunch of like, pipes and stuff sticking out of the ground. I can only imagine the type of stuff that's held in tanks underneath this place. We've got some chemical barrels out front and some whatever this is, debris, and oh man, I don't even want to know what's in here. But as part of the EPA Superfund program, over the course of the next decade or so, this entire site was actually remediated. So these are two extremely different things. If we actually go and look up, if we look up site data, we can actually find a data set from the EPA that shows us where all of the locations are. So we can find the polygons here. These are two very, very different data sets. We've got mollusks and we've got Superfund sites. How do we join those two data sets together to see how pollution impacts mollusks for our research sponsor, the Illinois Department of Mollusks? If we go back to our process, our research process back over here, let me pop this right back up. So if we go back to this, what we need to do is we need to load this data from the Illinois Natural History Survey, as well as the EPA, the Superfund sites. We need to clean that data and get it into a place where it can be analyzed. We need to find that data, analyze it, and then review the results. So we know where we need to get the data from outside PRI. We need to get it from the INHS Natural History Survey, as well as the Superfund site data set in the EPA. So if we pull that data down, these are both CSVs, we can actually pull them into our first landing zone, right, which is what we call Google Cloud Storage. Google Cloud Storage is an object-based storage system. That's a bunch of words that basically means you can put any type of binary data that you want here, including comma-separated values or text files like we have from the INHS as well as the EPA. And if I go into all the buckets that we have in our demo environment here, you can see that I've created a bucket. A bucket just holds a bunch of files or objects. I've created a bucket called source data. And if I click here, you can actually see that I've loaded a bunch of data sets already. And all I had to do was download the CSV from the website and upload it here into cloud storage. Very, very simple. And you can see that I've loaded two data sets. I've loaded the Superfund sites, and I've loaded this mollusk data here. So if I click on Superfund sites, you can see it's a bunch of GeoJSON files. And if I click on mollusks, there's all kinds of CSVs. There's several CSVs. There's identifications as well as occurrences. And occurrences is what we're interested in because it tells us where the mollusks have been seen. If I put on my IT hat for a second here, this is interesting to me as an IT person because I'm able to control the permissions for who can actually access this specific data set. And I can grant access, if I wanted to grant access to raw data, to a group of people. Let's say PRI researchers at illinois.edu. This could be a group of people. And I can do viewer, storage viewer, storage object viewer, and that person will only be able to read this data. They won't be able to change it or delete it or anything like that. I could also potentially add permissions on a bucket for a researcher or group of researchers to be able to upload data but not change it. There's all kinds of different things you can do. Very cool. All right, so IT hat off. So Great. Now it's in this cloud storage, but it's still in CSV file format, right? Like you could have kind of done that yourself and pulled it down to your laptop and, analyze the data using Python or something along those lines to parse your GeoJSON CSV. Why is this actually interesting? Well, it's interesting because it's actually very easy to get that data from this raw text-based format into something that is very easily analyzable in structured query language or SQL. And the way that we do that is through our product called Google BigQuery. Google BigQuery is a serverless data warehouse. What does that mean? That means that we can upload all kinds of different data into a structured format without having to worry about spinning up virtual machines, without having to worry about cores or memory or backend storage, or, oh man, we need to move all this stuff to flash disks so it's faster. Like, we don't care about any of that stuff. You just upload the data into BigQuery, and then you can do SQL queries against it. And if it's in a structured format like GeoJSON or CSV or something along those lines, it's very, very easy to add. So let's say that I'm in IT, and I have a bunch of researchers that all really, really, really care about a Mollusks data or the INHS data or something along those lines. I can actually very easily go in and add that data set from Google Cloud Storage, right? So I can click here in Google Cloud Storage, and then I can browse for the file that I uploaded. Here's my Mollusks data, and here's my occurrences. I can go ahead and select that. And then, yep, it automatically detected that the file format was CSV. I identify the data set that I want to put in. A data set's just like a holding, a holding object for a bunch of tables beneath it. So you can like set permissions so that people can see it or not see it or edit it or not edit it. And then I'll just come up with an occurrences, mollusk occurrences table. This is a database table. And then I can actually, this is really cool, I can auto detect the schema. If you look at a typical CSV file, the top row of the CSV file generally defines the schema of the file, meaning the names of the columns. So there's going to be an ID column, a unique ID for the row. There's going to be a species, right? So whatever species of mollusk that's been identified, there's going to be a geography column that's a point where the mollusk was, identified. There's going to be a month, day, year, who found it, all that other stuff. We can automatically detect that in BigQuery and pull it in. Why is this better and different? This is better and different because for most data warehouses or MySQL or basic databases, you actually have to come up with all that yourself. Like, you have to look at the CSV file, you have to create a SQL statement, you have to do SQL create table with schema, blah, 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 name all those columns, and then come up with the data types for each one of those columns. So if you have a data column that's a number, BigQuery wants to know, like, is this a number? Like, should I be able to add these two numbers together? And if you save it as a string, right, which is a collection of text, you won't be able to add those two numbers together. So figuring out the right column type for your schema is pretty time-consuming and labor-intensive. BigQuery actually does a pretty good job of identifying, just by the nature of the data that you're uploading, what type of data is in that column, and then it creates the proper schema based off of that. And then we can go ahead and just create the table here. I'm not going to do this because I already did that, but I just wanted to show you how easy it is to get data into BigQuery. So I'm going to quit this here. All right, so that was loading data into GCS. That was cleaning data using the BigQuery schema auto detection. If there are corrupted rows in auto detection, you can skip, you can configure a number of rows to skip so that you don't have to go through and manually clean all the data. If you've got 3 bad records out of 750,000, I don't really think you care. Maybe you do, but you probably don't. And you can just type in the number to skip those rows. So taking this off for a second. So we've got all of these really, really awesome data sets here in BigQuery, including our mollusk occurrences data, and we can see the schema for that here. You can see it's automatically detected the types for each of the columns. So we've got a catalog number here, which is integer. We've got the day of year, occurrence remarks, which is a string. Very cool. And then where's the geography? The geography is down in here, and that shows you where here it is, decimal latitude, decimal longitude. That's showing you where the mollusk was actually identified in an occurrence. So I'm going to switch over to my researcher hat now. Got a lot of hats here today. I'm going to switch over to my researcher hat, and I'm going to say, okay, you know, the project sponsor, this is my project sponsor hat. The project sponsor wants to know, how are mollusks being affected by pollution? And as a researcher, I say to myself, well, I better go find out if there's any mollusk data here in my Google Cloud environment. So I'm just going to go ahead and type mollusk. Sorry, you can tell I already did this. But that actually pulls up several data sets in BigQuery that happen to have mollusks in them. Oh, interesting. This is helpful. So if I go in here and click, that actually takes me right into this overview talking about what this is a product called Dataplex, right? We talked earlier about how this is Google search for all the kinds of data that you have inside of your Google Cloud environment. We can actually go in here and it'll tell me all kinds of different stuff about this data set, including the schema. And as an IT person, I might care about the data lineage here, which talks about where the data actually come from. You can configure this and have it show, oh, it came from, you know, this website, and brought it into BigQuery. But if we go back to being a researcher, this is fewer hats than I typically wear in my day job, by the way. I can actually open this directly up in BigQuery. And this will take me right to this data set. And again, I'm looking at the schema, but I can go ahead and click query here. And if I decide that I want to just see the first 1,000 records in this data set, boom, here it is. You know, these are all the different columns. And again, this was imported from a CSV file, and I did basically nothing to import it. All I had to do was click auto schema, and all these came up. So very cool. There's another cool thing that we can do here, which is, let's say that I only care about gastropods, but show me the number of occurrences in the class gastropod. Is it gastropoda? Gastropoda. Yep, that's right. And this is generating a SQL query for me, and I can just go ahead and run it. Oh, 39,000 occurrences of gastropods. So that's your snails and your slugs. That's pretty cool. I didn't have to write any SQL at all. And if I actually comment this out, you can actually see the entire total number of records in the database. So, wow, looks like about half, a little under half of the number of occurrences inside this database are for gastropods. Very cool. Anyways, we need to do a little bit more sophisticated analysis than just counting the number of gastropods in this research project. So what I'm going to do is I'm actually going to pop open what's called a notebook. And a notebook is a shared code execution and analysis environment. If you're a researcher, you're probably familiar with Colab, Jupyter Notebooks, that sort of thing. That's, you know, that is basically what we're looking at here. I'm actually going to collapse this so it's easier to see. What we can do with a notebook is we can actually collaborate very easily with other people on my research team. So I can manage the permissions here, and I can add a new researcher. We can say, you know, Mollusks research team at illinois.edu, and I can share this with all of the people on my research team, so we can all collaborate on this particular notebook. So pretty neat. What is the difference between using a notebook and analyzing data on my desktop or laptop? Well, if you look at this little thing up in the right-hand corner here, this is actually connected to a virtual machine inside of Google Cloud. Virtual machines in Google Cloud can get pretty big and pretty powerful. There are virtual machines that have many terabytes of RAM backing them. So if you need to do a whole lot of analysis, it's very, very easy and fast for you to get spun up with a computer that would be far, far, far more powerful than anything that you can readily access at home. I'm connected to this through my MacBook right now, and my MacBook would cry with the kind of analysis that we're about to do. I hope that's exciting for you, because it's exciting for me. So let's start off with using Google Earth Engine to display a map right here in the notebook. Cool, that's a neat visualization trick, but there's really nothing here yet, which is not very helpful from a research perspective. So what are we going to do? The first thing that we're going to do is we're going to use BigQuery. We're going to use SQL to get the mollusk occurrence data out of BigQuery. You can remember that we saw these mollusk occurrences before, right? There's a whole bunch of them. There's close to 100,000 mollusks, in fact, in this data set. How do we get that onto a map? And it's actually very easy to do that if we go ahead and run this step here. What this is going to do is using a SQL query to pull all of those mollusk occurrences and plot them right here on the map. And wow, there's a lot of mollusks all over the world. Oh, in Hawaii. If you have a research affiliate position open in Hawaii, I would love to hear about it. But as you can imagine, for the Illinois Natural History Survey, there's a significant large proportion of the occurrences which have been seen here in Illinois. And again, this is every single time a researcher out in the field has gone and saw, a mollusk of any type and has, picked it up, or maybe not picked it up, and observed it and just said, oh, hey, cool, look, check out this mollusk. This is the mollusk type. And you can see somebody was on the side of the road somewhere here under this highway and found and recorded having seen a mollusk. So lots of research happening, lots of field work happening all over the place. Very, very exciting. Cool. So we got the INHS data. What though? How does pollution spread? Pollution typically seeps into groundwater via watersheds. And what a watershed is it's the extent of area that a particular water, some chemical or water might extend through part of the water table. Somebody reached out to me the other day about the Muhammad Aquifer, which is an extension of many, many watersheds. But like the floodplain of a river would be considered a watershed, for example. So if you have a Superfund site that's sitting on a watershed, you can assume that the pollution in that Superfund site will extend not just to the boundaries of the Superfund site, but to the entire expanse of the watershed that it sits on. That's why these things are so dangerous, right? So we can assume that these mollusks. So all life needs water, right? And so if these mollusks are drinking water, which they are, all living beings need water. That if the Superfund site sits on a watershed and the mollusks are drinking out of that watershed, that they're going to be affected somehow. How do we find the watersheds in Illinois? You notice that the two data sets that I talked about in the beginning of this demo were from the INHS and the EPA. I didn't talk anything about watersheds. I didn't talk anything about state borders or anything like that. One of the really, really cool things about Earth Engine, Google Earth Engine, is that we actually have a set of data sets that you can very easily pull in without doing really any work at all. It's like a one-line pull-in, and you're able to pull in all kinds of different stuff. So the United States Geological Survey actually puts out a map of watersheds, of all the different watersheds across the United States. That is available in Earth Engine, so we're going to pull that in. And then the US Census has the borders of all the states in the United States. So we're going to bound the watershed data from the USGS by, we're going to filter it by just the watersheds inside of the state of Illinois. So let me pop right back to that. And I'm going to run this code. And you can see now that we have this, oops, let me get that out of the way. We have this map and it is looking at all the occurrences of all of these mollusks, and all of these little boundaries here are the watersheds, including Lake Michigan here. Were I looking at this as a researcher, I would go, oh my golly gee, I do not want to count all of the different occurrences within each of these boundaries. Maybe I can get a grad student to do it or spend a lot of time writing code. One of the great things about using Earth Engine and Google Cloud Notebooks is that because you have access to these very, very powerful back-end horizontally scalable compute systems, you can take this kind of analysis, which is a very expensive analysis, calculating whether how many of these occurrences there are within a watershed and everything like that. Calculating all of this analysis is very, very computationally expensive. So usually you would have to wait for supercomputer time, or have your laptop running on your desk for a couple months or something along those lines. We just did that analysis in less than 10 seconds. If you didn't notice while I was clicking that button, what we're looking at here is we're looking at an overlay. And if I pull this off, so take out the occurrences and I'll take off the watersheds themselves. What we just computed was the number of different species within the bounds of every single one of these watersheds. So the lighter or yellower colors, that means that there's more richness inside of the watershed. And the darker or more purple colors, that means that there's less richness. So there's maybe like 17 different species, or 20 or 40 or 50 different species within a yellow boundary. And there are maybe 5 or 6 different species within the purple boundary. I could put boundaries around this. I know that this all looks like a big yellow blob, but just remember that the extent of the watersheds actually looks like this. And you can see that there's areas in which no mollusks were identified at all. So if we pop off that, if we pop off the species analysis, you can see in the watersheds where there were no species, we didn't have the species richness calculated. So what did we just do? We just combined these two very different data sets, right? The watershed data set and the mollusk occurrence data set, and we combined them into a single data set. And we were able to show that certain watersheds have higher species richness and diversity than other watersheds. That's pretty cool, right? We're able to actually show like how healthy an ecosystem is, how the diversity of mollusk species is within different watersheds. But going back to my research sponsor, that doesn't actually get us to the answer of how does pollution affect mollusks for our Illinois Department of Mollusks. So as a researcher, I go back in and I say, all right, so I've got these watersheds and everything like that. What I want to do is I want to identify whether Superfund sites have richer or poorer species diversity. And again, we're assuming that a Superfund site that sits on one or multiple watersheds will affect all of those watersheds. So what's the species diversity here for watersheds that sit on Superfund sites? So we're actually going to take off all of these labels, and I'm going to show you the Superfund site. So you remember back in the BigQuery side here, we had imported the Superfund sites, and we have these site boundaries. This is the geometric extent of all the Superfund sites in Illinois. So I'm going to pop back to our visualization here. If I go down and I run this, so these are all of the different Superfund sites within within Illinois. And actually, if you remember our little spot in Taylorville, this is right by Manners Park, right? Central Illinois Public Service Company. So this is our original Superfund site back here. Going back to the map, what I want to do is I want to calculate the I want to calculate the richness of the Superfund sites using that's bounded by the mollusk richness that is bounded by the Superfund site. So again, this is an extremely computationally expensive thing to do because we're filtering both by the watershed and the Superfund site boundary, and then calculating how many species are within that intersection. So there's a lot of different mathematical steps that are happening here, and it's very, very difficult for a typical computer to execute. That's why this is going to take about 60 to 80 seconds to run. But what's happening in the background is we're not calculating this on my laptop. We're actually going out to Google's own Earth Engine diversified supercomputer, and we're able to take a look at and see what the, we're able to run those calculations in parallel rather than in series across thousands and thousands and thousands of cores. And interestingly enough, believe it or not, within Superfund sites, there's actually more species of mollusks and more species diversity than outside of Superfund sites. Huh. Now, if you're a researcher, I hope that you're starting to think to yourself, well, why is that? Why are there more mollusks in polluted sites? Does that have something to do with the remediations that have happened? Can we slice and dice the data by the remediation date and see if there's a comparison for remediated versus non-remediated sites? What specific species are diverse in here? Are they gastropods? Are they slugs or snails? I'm glad you're asking all those questions to yourself if you are, because that means that you're a cool researcher. But it also means that you are now empowered by Google Cloud to be able to answer those questions. All of those questions are available to answer at your fingertips. You can slice and dice this data. You can create those filters and find, go back to your SQL query and say, just give me the gastropods and that sort of thing. And you can rapidly iterate on this research to find the answers more quickly for the research sponsors. I hope you've enjoyed this demo. I really enjoyed it. I think we might have actually created a little bit of new knowledge here while putting it together. Turns out there's a lot of species diversity in Superfund sites in Illinois. And we did all of that in about, I don't know how long we've been recording this, maybe a half an hour or something along those lines. So if you're a researcher, if you're in IT, you're a research sponsor or something along those lines, talk to us. We'd like to help build research faster and create more innovative research. You can reach me at bradburns@google.com, or you can reach John Sakala, our relationship manager, at johnsakala@google.com. Thank you very much for your time.